Number 9 is 1 minus x squared dy dx equals 2y. So again, we want to find the general solution or solutions of this differential equation, and we want to know if it's explicit or it's going to be an implicit function. So we can start by separating our variables. So we can, think of this as over 1, right? This is really, there's your numerator and denominator, and we can just, again, cross multiply. So we have 1 minus x squared dy, right, because times 1 is itself, and then we have 2y dx. So again, all I did was, multiply the means and extremes. And our next step, let's see, we have x here, we have a function of y here. I'm going to go ahead and divide by 1 minus x squared on both sides, right? Or in other words, multiply by 1 over the quantity 1 minus x squared. This is a big 1. 1 times dy is just dy. And I'm left with, let's see, so we have 2y over 1 minus x squared dx. And so the next step, I'll probably divide 2y from both sides, because here's my dy, right? It's in the numerator, but I want this function of y on this side. I want to leave my function of x, right, my g of x, with my dx. So in this case, right, we're going to divide both sides by 2y, which is the same thing as multiplying by 1 over 2y. And so we have 1 over 2y dy, and we have our 1 over 1 minus x squared dx. So now we have our form that we wanted. We have, again, our f of y, right? It's a function of y with respect to dy, and we have a function of x, right, or g of x, with respect to dx. So we've separated our variables. So now we're ready to integrate, or we want to integrate, so we're going to integrate both sides. So the left-hand side, we want to integrate this function, but we can rewrite this, right? We can simplify this a little bit. Here's a constant, right? Our 1/2. We can take that guy, outside of the integral, and then we're just left with 1 over y dy. And the reason I did that, because it's easy to see, or hopefully it's easy to see. Let me just choose a different color here. The integral of 1 over y with respect to dy is the natural log of y, right? Because the derivative of the natural log of y is 1 over y. So that's, I mean, there's nothing wrong with leaving it like this, but it's a little bit clear to see the two parts here. And the right-hand side, we want to integrate by using partial fraction decomposition. So we are going to, let me get a different color here. Let's get green. Okay, so this guy, right, we're going to use partial fractions, right? It's a method you should have learned in integral calculus. So let's use partial fractions to simplify this guy, so we can write this as a product. And hopefully you can see the reason I'm using partial fractions is because I can factor this expression, right? This is a difference of two squares. So we are going to take a little side tour here. There's my, my arrow. Okay, so I'm going to work with rewriting this 1 over 1 minus x squared. So we have 1 over 1 minus x squared, right? This is a difference of two squares. From algebra, we know we can factor this polynomial as follows, right? 1 minus x squared 1 minus x times the quantity 1 plus x is 1 minus x squared, right? If you FOIL this, you're going to get this back. Okay, so we want to rewrite this as the sum of two parts, right, of two fractions. So one part is 1 minus x, the other part is 1 plus x. And I want to find coefficients, right? This is just a method, again, of partial fractions. If you are lost at this point with partial fractions, just open your calculus book and go to partial fraction decomposition, and you'll see some examples if you need a little bit more practice. We're going to be using this a lot, so that's why I wanted to make sure I do this problem. Okay, so we have this function of x, and I'd like to split it up into two functions, right, of x, because then we can easily integrate these two parts. So my goal now is to find my a and b. So we want to find our a and b, so let's go ahead and okay, so there should be parentheses around these. So I want to add these fractions. Well, in order to add these fractions, right, this needs a 1 plus x, so whatever we do to the bottom, we do to the top. We're really multiplying by 1. And similarly, 1 minus x, right? I'm just adding rational expressions. And I make this a little bit smaller. Okay, so now, so let's use some algebra just to simplify these guys. So we have, okay, this part is exactly the same. And we have, this is really a times the quantity 1 plus x over 1 minus x, 1 plus x, plus b times the quantity 1 minus x over 1 plus x, 1 minus x. And again, the denominators here are exactly the same, right? So we can write this over one fraction, 1 plus x, and we can just add the numerators. Right, and notice the left-hand side and the right-hand side, or specifically the denominators, right? These guys are exactly the same. So if you have two fractions that are equal to each other, and the denominators are the same, then that implies that the numerators have to be the same. So that's why in the next step, that implies 1 is equal to a times the quantity 1 plus x plus b times the quantity 1 minus x. So now the goal is to find a and b, these coefficients. So if x is -1, for example, then we have, and move this up a little bit, make this smaller. If x is equal to -1, then 1 equals a times 1 plus -1, right? I'm just substituting x for -1 plus b, 1 minus a -1. And again, notice this guy is just going to give me 0, so this is gone. Plus, this is really 1 plus 1, right? So that's 2b. And I'm left with 1 equals 2b. And so if I divide both sides by 2, b is a half. So that's one coefficient. Now to find the other one, what about if x is 1? So if x is 1, then 1 equals, and again, I'm just substituting my x values here. So 1 equals a times 1 plus b times 1 minus 1, right? So in this case, this is eliminated. And we are left with 1 equals, that's 2a, and so again, a is also 1/2. So now that we've determined our a and b, we can substitute our a and b back into our original function. So let's go ahead and, let's see, there's a lot going on here. We're not quite done yet, but let's see, where is it? Okay, so we started with, so this is what we had, right? and we wanted to rewrite this as two parts. Okay, so let me just want to be able to refer a couple of things. So okay, so from here, okay, I have 1/2, okay, ln of y, that's the same thing, the absolute value of y equals, okay, the integral of, and I want to write these two pieces, right, because that's originally what I wanted. So I have a over 1 minus x dx plus the integral of b over 1 plus x dx. And let me just write that x. Okay. So this is what I have, and now I can, again, replace those halves in there. So doing that, okay, so we have 1/2 ln of y equals, and I'm going to take that half and I'm going to bring it outside just because it's a constant. So 1 over 1 minus x dx plus again that half, the integral of 1 over 1 plus x dx. Okay, so now, again, this is the same times a half. So now, let me get maybe yellow. What is the integral, right, of this guy, and what is the integral of this guy? And again, from integral calculus, we know, let me get my white, that the integral of 1 over 1 minus x dx is ln, ln of 1 minus x, right? But I'm also going to multiply by a -1, so I need that negative. And I'll explain that in just a second. Let me just make this a little bit bigger. And then I have, okay, plus 1/2 times ln of 1 plus x, right, plus our constant of integration. So what I'm using is, we know that ln of f of x, right, if we take the derivative of this guy, that is f prime of x over f of x. Okay, wow, this is a long problem. Hang in there. We're at 12 minutes. It's a very good problem. Very good problem. It's tedious, but we're almost done, I promise. So where are we at? Okay, so now that we found our integrals, let's write, okay, so I'm right here. Right, so a lot going on. That's why I really emphasize the organization part, because I need to be able to read all your work and steps on your homework. Okay, so I'm going to multiply both sides by 2, because when I do that, then this is gone, right? If I multiply by 2, right, 2 over 2 is 1, 2 over 2. If I multiply the c times 2, I get 2c, but I'm just going to call it c because it's eventually just going to be a arbitrary constant. And the reason I did that is because, okay, now I have my ln's minus ln of 1 minus x plus ln of 1 plus x, and plus our constant of integration. Again, if you want to call this, I don't know, k, if that is it makes more sense, then that's fine. Okay, so now almost there. We have ln of y equals, and then here, ooh, this is a fun problem. We get to use, I'm excited, we get to use properties of logarithms here. So we can definitely rewrite this, right, probably as a difference. So let's, I'm going to write this guy first, and you'll see why in the next step, minus, this guy. I'm just changing the order. And I'm actually going to stop right now just because it's getting too long, so I'll continue it in the next video.